Hello everyone and welcome to the lecture on K-means clustering. We'll approach K-means clustering from a case study approach. We'll look at a data set of students, and this data set has various characteristics and has information regarding whether the student has any alcohol problems or any violent problems, how's the student's relationship with their parent, and if there is any family connectedness or not. So these are some of the features of our dataset, and our goal is to group students or cluster together students with similar characteristics into a cluster. And once we group together similar students with similar characteristics into subgroups or clusters, we can then approach that subgroup and then apply the interventions that we need so that we can help them out. Let's start by importing the libraries and modules that we need. I copied this from one of our previous lectures. Import pandas as PD, numpy as np, import series and data frames. We have matplotlib for visualization, and we have our magic function matplotlib inline to see graphs in our Jupyter notebook. First, let's use pandas read CSV method and check out our health data.csv. Let me copy this and then use pandas read CSV method, and I'll save our dataset in a variable called data. pd.readcsv. Okay. Next, let's call the head method to check out our dataset. Data.head. So these are the columns and some general information about our dataset. We have gender here, whether male or female, age, and notice here we have some missing values, no values here. We have age and a number of these columns. We have GPA, and I have left here so the meaning for some of the columns. Here means if you see alk probs 1, it means alcohol problems, and it has values from 0 to 6. Deviant 1 means, for instance, this deviant 1 column means it will give us information about a deviant behavior. We won't go into specifics of what is a deviant behavior or not, that's another topic, but we'll just approach and use these values to divide or subgroup our students into clusters with similar characteristics. And this viol 1 means violent behavior scale. DEP stands for depression. We have parental activity, parental presence, family connectedness, and self-esteem. So those are the meanings for some of these behaviors or characteristics. And for our approach, we will only consider the following variables. Okay, and you'll find out the meaning of these variables in here. Okay, so we'll use these variables, these clustering variables, to group together students with similar characters. If we call the tail method, data.tail, run it, we have about 6,500 rows. And let's call the info method, data.info. That's some information. The size of the file is about 1 megabyte, a bit over 1 megabyte. And here, if you see, we have some missing values as the number of rows is different for each of these characters, for each of these columns. You see here 6,504, 6,369, 4,800, and so on. So what we'll do is we'll drop any of the no values by calling the drop NA method. And let's also make all the column names uppercase. Okay, we can do that for better visibility. So we can use the map method and then make all the column names uppercase. Let's do that. So we'll take our columns and simply call the map method, and we have a string upper method, and then we'll apply it to our columns. Okay, and we'll save them. Once we convert our columns into uppercase, we'll save it in the same variable. And let's also drop no values from our data set, and we'll save it in the same variable data. That will be equal to data.drop any. Okay. Now if we check out our data set, we shouldn't have any NS. So data.head, and all the column names should be uppercase. Okay, looks much better, much nicer, I guess. And then if we call data.info and run it, now we see we have 4,601 rows. Okay, there is no missing value now, no missing data. And the size of the file is a bit lower now because of that. And this is what we usually do in data science, in data analysis. We spend most of the time in preparing our data so that we can use our data set for various purposes. Okay, and I have here, we will consider the following clustering variables. Okay, let's not forget that. Let me copy this. Okay, and then paste it somewhere here. What we'll do next is let's import all the libraries that we need for our k-means clustering. The first one is we need to import the train test split from scikit-learn's cross-validation from sklearn that cross-validation. Let's import train test and split. The next one is let's import k-means. We import the k-means library from scikit-learn's cluster from sklearn.cluster import k-means, and you can check out the documentation here for k-means clustering on scikit-learn. You can read more about any of the methods that we are going to use. We will also be using the pre-processing library, so let me import it now from sklearn import pre-processing. Yeah, those are this is learn, not lean. Let me run it again. So those are the libraries that we'll use mostly, and any other libraries that we need, we'll import them later on as we need them. Great. Again, our goal is to subdivide our dataset into subgroups, and we'll consider students with similar characteristics to form a cluster. And once we have that, we can apply various interventions to those clusters or subgroups, since they are going to have similar characters. And we'll be considering the following variables to do our k-means clustering. Okay, so I'll save this variables I'll save all these features in a variable called cluster, and then we'll simply index the variables from our data set. Okay, and here we have a few variables, about 8-9 variables, and in cluster analysis, those variables with larger values contribute more towards distance calculations. And since all of these variables are measured on different scales, we'll have to standardize them before we do any kind of clustering. Okay, that way our clustering will not be influenced by variables which are measured on larger scales. So for that matter, standardizing these variables is important, and when we standardize these clustering variables, they will all have a mean of 0 and a standard deviation of 1. So that's an important point to remember. And once we standardize them, our clusters will not be influenced by variables measured on larger scales. That's what we'll do next. And for that, we'll use a method known as scale, which is found in the pre-processing library. That's why we imported this. Okay, let's do that. So let's standardize our variables so that they will have a mean of 0 and a standard deviation of 1. What I will do is I will take our cluster data here, our clustering variables, and then make a copy, and I'll save this in a variable called, I'll just save it in a variable called cluster_s. You can save it anywhere that you like. Now what we'll do is we'll take each of these features and then apply the scale method on them. That way we'll standardize them to have a mean of 0 and standard deviation of 1. Okay, let's do that. So let's take the first feature here. I'll copy the feature and let's first index it. We have cluster_s, and then we'll index our first feature and we'll set that to be equal to, we'll call the pre-processing that we imported, and then it has a method known as scale, and we'll pass our feature name, so we'll pass it as an index. So I'll copy that and paste it here, and then we'll call the asType method, and let's pass float64 for asType. So what we're doing here is we are standardizing each of these clustering variables by using the scale method from pre-processing. So we call the scale method and then pass your clustering variable, and we'll convert it into a float64. Okay, and then once we did that, we just saved it in the same variable, cluster_s, and then our clustering variable name. Okay, so we'll do this for each of our clustering variables. So if I copy this and then paste it here, so I'll change this to the second variable, which is this. So we call the scale method and then pass the variable, our clustering variable, and then we'll change it to a float by calling the asType method. Okay, and what I'll do next is I'll just pause the video and standardize each of the clustering variables by doing the same thing. I'll just copy paste this and apply it for each of these clustering variables and then come back to it to save some time. Okay, now that we have standardized all our clustering variables, what we'll do is we'll calculate the average distance of observations from our cluster centroids, and later we'll plot the average distance to help us figure out how many clusters would be optimal for our problem or data set. And then we'll create some object called clusters, and that object will have a value range between 1 and 10, and we'll use that object to specify the number of clusters that we want to test. For us, we'll try out k values from 0 to 10, and next we'll create a mean distance object to calculate the average distance that we calculate for each of those 1 to 10 clusters, and then after that we'll find out which k value or which is the optimal number of clusters. And that's what we'll see in the next lecture. Thank you, everyone.